Hello everyone and welcome back to the AMOS project, our course on how to perform agile methods and open source software development. In the last session we looked at the basics of the team meeting, which for us in a Scrum course adjusted to university needs is the essence of in-person collaboration. In the team meeting, you finish the old sprint through a review, release, and retrospective subsession, and then you plan the new sprint in the sprint planning subsession. Now, all that planning needs to be externalized and put into a place, and to all that planning is tied the management of the project, so the actual project management. And in this slide deck, I will go over the planning documents, also called the process artifacts, that we require of you each week as homework, but that mostly serve your communication and coordination needs beyond in-person verbal communication. In industry agile methods, you may get lots and lots of tools. Here, we really try to simplify. The management of the project has been tied down to one Google Docs spreadsheet that you please work with many tabs, but it's really one place. And in that spreadsheet, you can see all the work that's going on. You can also see the mechanics behind it, so that you actually learn how things fit together, because you have to maintain it by hand. Later in a job, some tool may do that automatically for you, but for now, where you're trying or where you're supposed to learn it, it's good if you understand the relationships between various aspects of product and project planning and execution in these sheets. Software development has separate tools. We will be mostly talking about what the process owner, the product owner, and the Scrum Master will be doing. And product development itself will take place on GitHub and using Travis CI as the two required tools. In the following, I will go over the sheets of this particular spreadsheet document. You should have your own copy, clone it as you can from the links you can see here, and start working with it as I will explain now. Please make sure that the team coach and ultimately the AMOS teaching team has access to your spreadsheet, if only in read mode. So this spreadsheet has 15 different tabs, each for one particular purpose. And this may be a lot, of course. So this slide deck serves documentation as well as explanation purposes. And you don't have to understand all of this at once. Rather, we will discuss the different topics during this course in a particular lecture, and only after you've heard about it in class should you start possibly filling in these tabs and providing the information. The course schedule slide deck spells out what is needed when in each of the course weeks as your deliverable, as your homework. So these 15 tabs are there in the planning documents. And here's the first tab, very simple, easy to get started. Please provide us with the basic project information. This, for example, is a link to this document for easy copying, so use a URL shortener. Then there is the production system or test system. By that we mean how and where you deploy your software after build. There's no single way of how a project deploys, because that depends on the particulars of the project. A Raspberry Pi project may be very different from a web service or web-based project. As a consequence, you have to figure it out yourself. What we do ask of you, what we require, is a link here though to the GitHub repository where you're developing your software, as well as to the Travis CI dashboard where we can see the status of the build and whether it works or not, how the tests look like, etc. And feel free to extend this spreadsheet with additional information you find useful or you want to communicate to us. So in this slide deck, after giving you an example, I explain the different aspects of that sheet, and so you can use this to look up what it means after you've listened to this session. So second tab is also quite simple. It's the team. Please provide your name and contact information. And also feel free to extend it. So provide not only your GitHub ID, but perhaps Skype ID or channel nickname, whatever your team chooses for communication purposes. Then everyone in a given team plays various roles over the course of the project. The product owner and software developer roles have been assigned statically, typically, not necessarily, but at FAU they have. And in addition, there are dynamic roles, however. So the Scrum Master role and the Review and Release Manager role, they need to be assigned. So we recommend strongly that you plan this out once at the beginning of the project, and you plan it out in such a way that beyond the static roles, everyone gets to play in equal measure the Scrum Master and the Release Manager role. If the POs can't play the Review and Release Manager role, then make it only the software developers. But ideally, everyone gets the learning experience of playing Scrum Master and Release Manager roles. And you can see it here, plan it out over the course weeks, add the course and the dates if you like. So we're finally getting into the actual content of the project. As explained in class, each project has a mission which describes what the specific project is to achieve. But that is only a part of the overall product vision, because the software being developed, the overall product, may last longer than this particular project. So a product vision is the overarching vision of what's being developed. It's timeless, it may never fully be achieved, and it's a list of, or it provides the purpose of why the software is being developed, its core functionality, if you will, and always has potential for more functionality based on fulfilling that, trying to fulfill that vision. A project, as opposed to a product, is time-bound. A project has a start date and an end date, like your AMOS project that you're carrying out. So the project mission describes what you set out to achieve within the time frame of the actual project. So it's much more specific, and you much more precisely describe what can be achieved realistically by your team under the given circumstances. Both vision and mission should be short and sweet. Each team needs to talk about what the customers, what the users want. And more often than not, team members may not be familiar with the terminology or vocabulary in a given domain. None of you are probably banking or financial services experts, yet you will need to understand precisely what an interest rate is, or a financial products portfolio, or a put or a swap or whatever the domain may provide you with technical vocabulary. So while you will ultimately implement it as code for communication purposes, in particular with non-technical people, you need to give it precise definitions. Typically that's done using a domain model, perhaps described using UML, But then not everyone is familiar with UML, and and hence we have a glossary as a much simpler version of a domain model, and this glossary provides the key terms from the domain with a crisp definition. As you can see here, the glossary is simply a list of terms and their definition. Here you can see examples. Well-defined terms or good definitions of terms follow a common pattern where it says X is like Y with this additional refinement or additional information. It's usually this additional information cannot be contradictory, otherwise it's not an is-a relationship, but rather it should be a descriptive is-a form of a noun definition. You may also have synonyms and shorthands, etc. in the glossary as the poor man's approach to a domain model. All right, on to planning. Each project, not in the beginning, but as explained in the course schedule documents at some point of time, each project needs a release plan. In the AMOS project, we have a midterm release and a final release. And so we have 2 product releases, each of which is substructured into a sequence of sprint releases based on the sprints. So as part of the release plan, you map out the whole project, and for each sprint you list the number of product backlog entries or features, functionalities you want to do in that sprint. And you don't do it just for the next upcoming sprint, rather you do it for the whole project. So while you may be less precise for the later sprints than for the current sprint, the product owners do have to provide an overview of what is to be achieved, given current understanding and current prioritization of features, need to provide that what needs to be achieved as this release plan. And again, it's split into 2 parts. And the way the release plan is structured is for each sprint, you have a theme. You list the features, functionalities you want to achieve in that sprint, and using the help of the software developers, you estimate, provide an initial estimate of the total size of a sprint. And then you add them up to a total product release size. And then you can see, as done in the spreadsheet, you start counting down. So on the one hand, you just count how many story points, what's the size of a given sprint, but then you know what's supposed to be achieved in the whole product release, adding up the sizes of all the sprints. And then you can count down by taking the total product release size and subtracting sprint by sprint. And what you do with the release plan is, it's a living document. So what you do with the release plan is you adjust it. After each sprint, when reality has happened, you provide the real data as opposed to the original estimated, predicted data. So in the way we handle release plans, you list it next to each other. You have the original prediction, and then you have the reality. And you keep it next to each other so that you can historically compare how good your predictions were. Now, let's assume you're in the middle of some product release. So you've got a couple of sprints under your belt, but several coming up. Well, you adjust the remaining sprints from your perspective as to what can be done. So the reality of a given situation is such that what has become manifest, because it's history now, and what you predict to remain. And that way, at any given point of time, you are zeroing in or refining what can still be achieved. So you know what has been achieved up till now, and then you list and provide what can still be achieved given the current development speed, etc. And so this type of planning, it's not very visual or very easily graspable here using just the raw numbers. So for that reason, we've now got the product release burn down chart, where you can see visually how you are zeroing in on what you captured as the overall deliverable in terms of functionality for a particular product release. So here you can see data for the midterm release in the form of a burn down chart, and you're burning down from the original estimate. You're burning down to what you can possibly achieve, and you can see how the real burn down continuously adjusts based on what you learned historically, what you just achieved, and what you still plan to do. So in this case, you were a little bit too optimistic and you adjusted that as reality kicks in, but otherwise this is pretty straightforward. In addition to measuring the burn down towards the product release goals, you also track your velocity or development speed. So you want to know the size of sprints that you can take on in terms of story points. And as explained, the particular size of a team, the average size doesn't matter, but you want to get there to be consistent, that consistently in a given sprint you achieve a particular size, particular number of story points. So it doesn't matter whether it's 20 or 40, you just try to consistently estimate same size features as being of the same size using that table of story points I provided last time. Here you can see the development speed charted out once. That really should be constant. The reason why it's going down here at the end, I'm not sure. Maybe it's because you are trying to be slower as you zero in on a product release. It may also simply be that you overestimated the size of this particular team, overestimated the size of what was possible. If you go too fast, you will incur many bugs. Those bugs will come back to haunt you, bringing down your development speed later on. All right, onto product backlog. We are now solidly at the core of sprint management, and we've discussed this as part of the project crash course. So let me be short and sweet here. The product backlog is a list of functionality to be implemented. It's structured from the top to the bottom, where the top features are the highest prioritized features and should be of crisp and clear quality in their presentation, while what's further down the backlog may be a bit more vague. High quality needs to be all those things that are coming up for the next sprint and maybe the product release. And this is a living document, so you jot down further down what's coming up and refine it and make it precise over time, always in sync with the release plan. In a sprint backlog, you capture, as you already know by now, what the team committed to as implementing in the upcoming sprint. So it's what used to be just a few moments ago during sprint planning, the top prioritized items in the product backlog. You copy them over from the product backlog into the sprint backlog after you estimated the size. It's also the place where developers allocate features to each other. As we will see, one of the simplifications of the AMOS project to make Scrum work for university settings is the collapsing of user stories / features with tasks. Usually we make it such that features are so small that they are actually tasks that can be picked up immediately by one developer. Sometimes teams make features larger and then they have to break them up into in a separate step into tasks, maybe using a Kanban board. That is common practice in industry. Again, we strongly recommend the simplification in the beginning of features mapping one-to-one on tasks that then particular developers pick up and commit to as implementing next. Then, if you finish the sprint as part of the review and release, you sign off on features, and if a particular feature from the sprint backlog got signed off on, it will end up in the feature archive. If it wasn't finished, it will go back to the product backlog, as also discussed previously. And we're switching now from the core planning and review release process to the process improvement parts of Scrum. Also in this spreadsheet, we maintain the so-called impediments, current problems that hinder the team from achieving progress. And these types of problems or impediments are non-technical ones. And the Scrum Master is responsible for managing them, and they get managed in the impediments backlog. Like a product backlog, what a product backlog is, or what a sprint backlog is for features, is the impediments backlog for current non-technical problems. So you see two examples here, one team process and one customer communication problem, and it's the Scrum Master, either the current Scrum Master's task to work on these and possibly fix them before, as organized in the AMOS projects, before they hand over this work to the next Scrum Master. When teams sign off on features as part of the review process, they need to ideally do so in a consistent way. So it can't be that one sprint everything's signed off on and at low quality, and next sprint high quality requirements are posed and nothing is signed off on. For that reason, to be consistent on sign-off decisions, Scrum provides the notion of definition of done, a checklist of things that need to be fulfilled in order for some entity, some item to achieve done status. What that item is, that depends. We have, or there are definitions of done on the level of a single feature or product or sprint backlog entry. There's definition of done on the overall sprint and on the overall product release. A feature definition of done obviously serves to sign off on a feature. Can it go into the feature archive? A sprint definition of done signs off on can the sprint results be released, and a product release definition of done signs off on can the overall product be deployed. We will cover definition of done, its purpose, and the embedding in the overall process as one of the later lectures. This is not something you need to do or get right from the beginning. Well, no project without good documentation. Ideally, you do it as you go along, and we need you to provide at least a link to where that documentation is. Ideally in the GitHub repository, need you to provide a link to that documentation here, or simply explain how to find it. Finally, any good project has a bill of materials, a Stückliste in German, which lists or shows what's included, what's in that package. And typically these are the libraries that some project uses. These days, this is all the open source libraries that you are using, and those should not be sneaked in under the hood. These should always be very explicit team decisions. Please think back to our rules on good open source governance. You need to decide as a team, A, that you want to use this component so you don't surprise your peers. And B, you need to figure out whether it's actually a usable component, because we request that you only use permissively licensed open source components. So once you decided that this is the component you want to use and you can use it, then put it down as part of the bill of materials here, provide the version that you're using, and provide the license if it's an open source component. And as these things change, please update them so that in any given deliverable, the bill of materials is correct and consistent and complete. That's it from me. This document, the planning documents, aka process artifacts, please clone them. They are a core part of managing the project, and the product owner should submit them every week as part of the weekly or sprint deliverables using our cost management system. That's it from me now. So far so good, and see you in the next session.